we are going to discuss a relation which is known as de Broglie equation. De Broglie equation is lambda is equal to h upon mv. Okay, this is called de Broglie equation, where lambda is the wavelength of matter wave. Okay, matter wave is a new kind of wave. I think you have heard it first time. Matter wave is a wave which is associated with every mass. Okay, because in classical physics we are considering that wave is another thing and particle is another thing. Okay, but in quantum physics, which is another branch of physics, we are considering that all the particles have its own wave, and that is called matter wave. Okay, so we are going to find out the relation between among these physical quantities. So lambda is wavelength of matter wave, h is Planck constant, and mv is mass and velocity respectively. Okay, so we when we are going to start it, we don't have this relation. We just know that lambda is depending on mass, velocity and Planck constant. Okay, but with the help of dimensional formula we will find out the same relation. Okay, so let's see. We will discuss one more example to understand third application of dimension analysis, and for that we have taken one example here. Suppose wavelength is given, wavelength which has the symbol lambda. Okay, it is written here lambda. Take is depending on the mass of the particle, velocity of the particle and Planck constant. M is for mass, V is for velocity and H is for Planck constant. Okay, then we have to find out the expression for this. Okay, we have been given that wavelength of any wave is depending on mass, velocity and Planck constant, and therefore we have to find the relation among them. Okay, so let's see. We have written it in a mathematical term, you can see, and by replacing the sign of proportionality we have included one constant which is k, and we know that this k is dimensionless. Okay, taking dimensional formula both sides, LHS and RHS, we will have the dimension of lambda. Lambda is a wavelength, and you know what is wavelength. Wavelength is, suppose this is wave. Okay, so the distance between these two is called wavelength. Okay, so it is the length, and therefore the dimensional formula for this will be L, and for convenience we have written here M0 L1 T0. Okay, and in right hand side k is dimensional less, no need to write. M is mass, and therefore it will be m power a. Velocity we have for velocity lt minus 1, and b is given, and h is Planck constant, and for Planck constant we have dimensional formula ml2 t minus 1 power c. I have told you that it will be better if you will learn more and more dimensional formulae for different physical quantities, because it will help you in everywhere. Sometime 1 mark question are being asked to tell the dimensional formula of any particular physical quantity, so it is better to know more and more dimensional formula for the physical quantities. Okay, so for Planck constant it will be ml2 t minus 1 power c. Okay, now by calculating them we can see that m is coming 2 times, not here. M is in this square bracket and this square bracket, and therefore it will be m power a plus c. Okay, and L is also in 2 square brackets, and therefore it will be L power b plus L power 2c. okay, and T is in second and third box, and therefore it will be T power minus B minus C. Okay, you can see it. So we have m power a plus c, l power b plus 2c, and t power minus b minus c. As we know that if the base is same, the power will be added whenever they will be multiplied. Okay, comparing the powers of both the sides LHS and RHS, we can see m power uh, is 0 in left hand side. Here you can see m power 0, and here you can see m power a plus c, and therefore by comparing them we will get a plus c is equal to 0. Here it is l power 1, and here it is l power b plus 2c, and therefore we will have b plus 2c is equal to 1. Okay, and here t power is 0, and here t power is minus b minus c, and therefore it will be minus b minus c is equal to 0. After calculating, we can see here that a plus c wait a minute. We can see here that calculating this term, we will have a is equal to minus c, and calculating this we will have b is equal to minus c, and in both these two we can see that a is equal to minus c, b is equal to minus c, and therefore a is equal to b. Okay, is that clear? So we come to the conclusion that a will be equal to b, and a and b both are equal to minus c. Okay, so next, here you can see that we have put the value b is equal to minus c in the second equation. Here you can see this term is put into second equation. So b is equal to minus c, and when you will put b is equal to minus c in place of b, we will have minus c plus 2c is equal to 1. By calculating 2c minus c, we will have c is equal to 1. So what we can say here, that c is equal to 1, and as you have seen that minus c is equal to a plus a and b, so you can write that c is equal to 1, and as minus c is equal to a, and therefore a will be minus 1, and b is equal to a, therefore b will be minus 1. Clear? So that we have discussed before is written here. We have a is equal to b is equal to minus 1, and c is equal to 1. Putting a, b, c in the above equation, in equation 1 we have lambda is equal to k m power minus 1, v power minus 1, and h power 1. Okay, so when you will bring lambda is equal, you can see here that m is with minus power and v is with minus power. So when you will bring it to denominator, it will have lambda is equal to k h power 1 means h upon mv. So this is the result that we have found by using dimensional formulae. Okay, this is dimensionally correct because we don't need to write anything for k if we are discussing with respect to dimensional formulae. Understood? But experimentally we have the value of k, and that is k is equal to 1. So if we will put k is equal to 1, we will have lambda is equal to h upon mv. And one more thing we can see here, the value of Planck constant is written, so you must remember it. The value of h, that is called Planck constant, is equal to 6.62. okay, is 6.62 into 10 power minus 34. Okay, and its unit is kilogram meter square per second. Okay, so remember this term, and it is uh, used to find the energy of photons. Okay, as we know that light is made up of photons, so whenever we have to find the energy of the photon, we are using this term, so remember it. Next, H is equal to 6.62 into 10 power minus 34 kilogram meter square per second. Okay, we have the result that we have already discussed. Experimentally we have k is equal to 1, and by putting k is equal to 1 we will have lambda is equal to h upon mv. So with the help of dimension analysis we have expressed the relation among lambda, Planck constant, mass and velocity. Now I think this is sufficient to understand the application. I will give you some numerical based on it, and one topic is remained, that is limitations of dimension analysis. So in next video we will discuss on some numericals, and we will discuss the limitations of dimensional analysis. Okay, till then, bye.